The observable universe is huge. Hundreds of billions of galaxies. Hundreds of billions of stars in a single galaxy. And around those stars, planets. So here is the core contradiction: if the cosmos is so large and so old, why does it seem so quiet? No obvious signals. No confirmed visitors. No unmistakable signs of galactic civilization. That silence is the first clue. The Fermi Paradox is not really a single question. It is the feeling that something about the numbers does not add up. To understand the paradox, you need scale. The Milky Way is massive. Our star is one of many. Our planet is one of many. And the age of the universe gives intelligent life a long runway if the right conditions occur often enough. That is why the question keeps returning. If intelligence can arise here, and maybe elsewhere, then why do we not see a clearer cosmic footprint? Why no unambiguous beacon? Why no probes? Why no self-evident evidence of someone, somewhere, having already crossed the stars? The silence becomes stranger the longer you stare at the numbers. Here is the uncomfortable detail. We only know one planet where life happened for sure, Earth. That means every theory about alien life is built from a sample size of one. We can estimate. We can infer. We can model. But we cannot yet compare Earth to a full catalogue of inhabited worlds. That makes the paradox both thrilling and dangerous. It is easy to overstate what silence means. It is also easy to dismiss the silence too quickly. The real mystery lives in the middle: enough evidence to ask the question seriously, but not enough to answer it cleanly. One of the most famous explanations is the Great Filter. Maybe life is rare. Maybe simple cells are hard to get. Maybe complex cells are hard to get. Maybe intelligence is hard to get. Maybe technology is easy to destroy. The filter could be behind us. Or ahead of us. That uncertainty is what gives the theory its power. It reframes the silence as a survival problem. If the universe is full of potential worlds, then the absence of visible civilizations might mean something is stopping most of them long before they become obvious. That is not a science fiction answer. It is a hard statistical question with existential stakes. Another possibility is much simpler. We may not be looking the right way. Civilizations could communicate in ways we are not tuned to notice. They could exist at distances that make detection difficult. They could be quiet on purpose. They could be brief. They could be common but scattered. Or they could use technologies that leave little obvious waste heat or radio leakage. That matters because Fermi Paradox is often framed as a cosmic ghost story. But a lot of the time, the problem is more ordinary than that. We are searching a huge dark room with a tiny flashlight. The absence of evidence may not be evidence of absence. Then there is the zoo hypothesis. Maybe advanced civilizations are out there and intentionally not contacting us. Maybe Earth is observed, but only from a distance. Maybe we are left alone for the same reason wildlife is left alone in a protected reserve. This theory is popular because it turns silence into policy. Not emptiness. Restraint. It gives the universe a hidden social rule. But it also raises a new problem. If everyone is quiet on purpose, how do you ever prove the rule exists? The mystery does not disappear. It just becomes harder to test. The dark forest idea is darker still. Maybe intelligent life stays quiet because the universe is dangerous. If you reveal yourself, you risk attracting something stronger. In that version of the story, silence is not politeness. It is survival. That idea hits hard because it turns the cosmos into a place where caution beats curiosity. Every signal becomes a risk. Every broadcast becomes a footprint. And the night sky stops feeling empty and starts feeling cautious. This is where the paradox becomes emotionally powerful. The silence may not mean nobody is there. It may mean everyone is listening. SETI and other searches are not magical ears pointed at the sky. They are limited instruments, limited time, and limited assumptions. We search for signals we know how to recognize. That means a civilization could be there and still miss our filters entirely. The problem is not only distance. It is interpretation. If a message is brief, weak, directional, encrypted, or unlike anything we expect, it may never look like a message at all. So when people ask why we have not heard from anyone, the answer may be less dramatic than a cosmic conspiracy. We may simply be listening through a very narrow doorway. If we ever did detect a clear signal, the impact would be enormous. It would not just prove we are not alone. It would force us to rethink how common intelligence is, how long civilizations last, and how fragile technological life might be. Even a faint, unambiguous beacon would change the story instantly. The silence would suddenly have a boundary. And that is why the paradox matters now. It is not a complaint that the universe is quiet. It is a guide to what we might be missing and what we are hoping still exists. What makes the Fermi Paradox so durable is that every answer creates a new problem. If life is rare, why did it happen here? If life is common, why so quiet? If civilizations are hidden, why hide? If civilizations are brief, what usually ends them? This is the engine of the mystery. The question keeps surviving because the universe is large enough to keep all the options alive. That is also why this topic works so well for a documentary channel. It is conceptually huge. It is visually flexible. And it rewards careful language instead of sensational claims. The Fermi Paradox does not prove aliens exist. It does not prove they do not. It does not prove we are alone. It does not prove we are being watched. What it does prove is that the question is legitimate. The numbers are real. The silence is real. And the gap between them is what keeps researchers, writers, and viewers coming back. That is a powerful place to stand. Not in certainty. In a frontier of uncertainty that still has room for evidence. One way researchers push against the silence is by looking for technosignatures. Not just radio. Not just lights. But clues that technology might leave behind: unusual atmospheric chemistry, engineered heat signatures, odd repeating patterns, or structures that do not fit natural explanations. This makes the search broader, but not simpler. Every candidate signal has to survive skepticism. Every anomaly has to beat the possibility of noise, instrumentation error, or natural astronomy. That is why the field moves carefully. The universe may be full of signals, but a real discovery has to be unmistakable. Another explanation is that civilizations may not last very long in detectable form. A species could invent radio for a moment and then move on to quieter technologies. It could stabilize quickly, reduce waste, and become hard to notice. Or it could collapse before it becomes obvious at all. If that is true, the cosmos may not be silent forever. It may just be quiet between brief flashes of activity. That idea is haunting because it turns the paradox into a timing problem. Maybe the universe is not empty. Maybe we are simply not overlapping. So what is the Fermi Paradox, really? A reminder that the universe is so large it makes silence feel suspicious. Maybe life is rare. Maybe civilizations are hidden. Maybe we are early. Maybe we are late. Maybe we are just not good at listening yet. The truth is that the paradox is less a solved riddle than a mirror. It reflects our fear of being alone and our hope that we are not. That is why it lasts. The stars do not answer. They only keep the question alive. If the silence of the cosmos made you look up differently, stay with the Mystery Atlas TV. The next investigation follows another place where evidence, scale, and uncertainty collide. Subscribe for the full series, and tell me in the comments whether you think the silence means we are alone, hidden, or just early.